Assalamualaikum warahmatullahi wabarakatuh. So my group will present about the solid state laser. First of all, the group member is Mahasniza Ibrahim, Faris Zahari, Faris Mustapha, and me myself, Syarfa Najihah. Okay, for general knowledge, there are 4 types of laser. First of all is solid state laser, gas state laser, liquid state laser, and the semiconductor based laser. And my group will focusing on the solid state laser. So what is the principle of operation for the solid state laser? So generally, the active medium of the solid state laser consists of the glass and crystalline, which is the host material, and a dopant material such as neodymium, chromium, erbium, thulium, and ytterbium is added to the host material to produce an active medium. Okay, so solid state laser is optically pumped. So what is optically pumped? Optically pumped is a process where a light is used to rise up or to pump the electron from a lower energy level to a higher one, so that the molecule or the atom achieve the population inversion. Okay, and population inversion is a state where the number of electrons or a group of atom or molecule is in a higher number of member. Okay, so if you can see the picture on the above at the left side showing you the ground state, which is the E1, where the laser transition is from E1 to E2. But with the pump transition or with the optically pump process, the electron is pumped from the E1 to E3 instead of E1 to E2. And at the right side of the picture, showing you the absorption process occur from the E1 to E3 with the optically pump process, and the rapid decay of the electron produced from E3 to E2, and the stimulated emission process is occur from E2 to E1. Okay, the optically pump process can be used either by using the flash lamp, arc lamp, or the diode laser.
The working substance of a solid laser consisting of optically transparent crystal or glass as the base material, both doped with activated ions or other active substances. The working material should have 4 characteristics. First, it should have good physical and chemical properties. Second, it should have broad absorption bands. Third, it also should have narrow fluorescence spectra. And lastly, it also should have high fluorescence quantum efficiency. So for glass laser working materials are easy to be made into even large size material and can be used in high energy or high peak power lasers. But its fluorescence spectrum is wide and its thermal performance is poor, so it is not suitable for working under high average power. Common neodymium glass has silicate, phosphate, and fluorophosphate glass. In the early 80s, neodymium glass with negative refractive index, negative temperature coefficient was developed. It can be used in medium and small energy lasers with high repetition rate. So for crystal laser working materials generally have good thermal and mechanical properties, narrow fluorescent lines, but the technology for obtaining high quality large size materials has complicated crystal growth. So that's all from me. Thank you.
Okay, now let's move on to the type of solid state laser. There are 3 types of solid state laser. The first one is ruby laser, the second one is neodymium glass laser, and the last one is neodymium yttrium aluminium garnet laser. Now let's move on to the first type of solid state laser, which is the ruby laser. Ruby laser is a red solid state laser based on a synthetic ruby laser crystal as gain medium. Gain medium can amplify the power of light, typically in the form of light beam. Ruby laser is the first laser developed in 1960 by Kidor Maiman, and he demonstrated the free-running flash lamp pumped by ruby laser. Flash lamp is where gas discharge lamp are used for generating intense light pulse. Ruby laser belongs to the relatively few solid-state visible laser. Visible laser is laser that emitting visible light. Most lasers are emitting in the infrared spectral region. Infrared is invisible light with vacuum wavelength. Ruby laser is a 3-level laser system that requires quite high pump intensity for producing laser gain. 3-level laser system is the laser transition that ends on the ground state. Ruby lasers are pumped with flash lamp either in the free running mode with pulse duration of 1 millisecond or with Q switching for nanosecond pulse with corresponding higher peak power. Q switching is a method to obtain energetic pulse from laser by pulse generation. The second type of solid-state laser is neodymium glass laser. The host of this laser is glass, which is an excellent host material for neodymium. The attraction for glass is well-developed technology for making large-size glass laser with good optical quality. Glass laser is very high output energy per unit volume of material. Glasses are more suitable for high-energy pulse operation because of their large size, flexibility in their physical parameters, and the broadened fluorescent line. Glass laser can be doped at a very concentration with excellent uniformity, and it also can be made in a variety of shapes and size, from fibers a few micrometers in diameter to rods 2 meter long and 7.5 centimeter in diameter, and this up to 19 centimeter in diameter and 5 centimeter thick. The major disadvantage of glass is a low thermal conductivity. The last type of solid-state laser is neodymium yttrium aluminum garnet laser. This laser is based on the neodymium ion, which is a rare earth metallic ion. The host is the YAG. In YAG laser, ion neodymium take place at yttrium ions. YAG offers low threshold and high gain. YAG is a very hard isotropic crystal. YAG is also a good thermal and mechanical properties. This laser can be grown and fabricated in rods of high optical quality. This type laser uses 4-level laser system which requires lower pump energy compared to the ruby laser. The efficiency is about 10 times as compared to ruby, and YAG laser also has drastic weight reduction.
Now we move to my part, which is advantage and disadvantage of the solid-state laser. For the first one, for the advantage is no chance is wasting material in the active medium, because here material used is in the form of solid. For the second one is the construction of solid-state laser is comparatively simple. For the third one is cost of solid-state laser is economical. For the disadvantage, for the first one is output power is not high as the CO2 laser, which means the carbon dioxide laser. And for the second one is the efficiency of the solid-state laser is less than the CO2 laser. Now we move to the last part, which is the application of solid-state laser. Solid-state laser, there have 3 types of solid-state laser, which is the ruby laser, YAG laser, and glass laser. For the first one is ruby laser. The ruby laser been used in the holography, tattoo removal, and diamond drilling. The operation wavelength for the ruby laser is 694.3 nanometer, and the pump source for the ruby laser is flash lamp. For the second one is the YAG laser. YAG laser has been used in the resistor trimming, silicon scribing, and marking. Mostly, the YAG laser has been used in the semiconductor industry. The operation wavelength for the YAG laser is between the 1.064 until 1.32 micrometer, and the pump source for it is the flash lamp and laser diode. For the third one is the glass laser. The glass laser being used in the telecommunication sector, for example, the optical amplifier. The operation wavelength for the glass laser is 1.53 until 1.56 micrometer, and the pump source for the glass laser is the laser diode.